Hello students, hello everyone. This is Senior College Mathematics. Topic of discussion is algebraic process. If you are in SS1, SS2, SS3, or you are preparing for WAEC, NECO, GC, NAPTEP, JAMB, or any other external exams into high school, this lesson is for you. Lesson 9, Simplification of Algebraic Fractions. Simplification of algebraic fractions. This group of fractions involves the product of numbers and letters or letters only. Okay, so this is done by applying same principles as in the case of fractional numbers only. What is the principle? The principle of finding LCM. You find the LCM, you simplify, you add common terms where possible. The basic rules of addition, subtraction, basic rule of addition, subtraction, multiplication, and division also apply same way. So all we are doing is the same as solving your normal fractions, except that this case involves letters. It involves letters. Okay? Examples: simplify the following algebraic expressions. Before that, for updates, follow Voice of Petakus via YouTube at PetakusEduCom. To do that, subscribe to this channel, like and share this video to your friends, your colleagues, to your classmates. Facebook, fb.me/PetakusEduCom, Instagram at PetakusEC, Telegram t.me/PetakusEduCom. In all of these platforms, you get updated about what is happening at Petakus education community from time to time, where you have access to quality, unlimited, and simplified mathematics teachings in series. Okay, so we look at the first set of operations: addition and subtraction. Addition and subtraction. So we have example 46. Simplify 2/a plus 7/b minus 3/c. The LCM of the denominators a, b, c is a times b times c. So you write down the LCM, your division line. So if you divide the LCM a, b, c by denominator a, you are left with bc that will multiply 2. If you divide the same LCM by denominator b, you are left with AC that will multiply 7. Then minus, if you divide the LCM ABC by C, you are left with AB that will multiply 3. So you have 2BC plus 7AC minus 3AB. You can only add or subtract when there is common letter, but if you check through, there are no common letters, so we cannot add nor subtract further. So you leave your answer the way it is. You have simplified. Okay, example 47. You have 3/s minus s/2 plus 5. Now there is what I call a balanced fraction. A balanced fraction is a fraction such that all the numerators have their respective denominators. So to have a balanced fraction from example 47, you simply write 5 as 5 over 1. So this is what I call a balanced fraction, so that you can find the denominator and simplify easily. Okay, you can find the LCM. You can find the LCM and simplify easily. So the LCM of S2 and 1 is 2s. Is 2s. So you write down the LCM as 2s. If you divide 2s by s, you have 2. Then 2 multiplied by 3 minus. You divide 2s by 2, you have s multiply by s. You divide 2s by 1, you have 2s multiply by 5. You multiply, you have 2 times 3, that is 6, minus s times s, s squared, plus 2s times 5, that is 10s. So if you want to follow order of arrangement, you know, in quadratic equations, either you have the power of the unknown, as in the term that contains square, you have it first or it comes last. So the middle term always contains s, or the variable you are working with. So in that order, you can write the answer as 6 plus 10s minus s squared all over 2s. 6 plus 10s minus s squared all over 2s. We cannot simplify further than that. So that is the answer we have for simplifying that algebraic fraction. Okay. Example 48, you have 5 over 2cd plus 4 over 3de. If you check 2 and 3 first, the LCM is 6. If you check C, D, D, E, D is common, so D will appear once. So the LCM of C, D, D, E is C, D, E. So the LCM of 2CD, 3DE become 6CDE. So you write down the LCM 6CDE. If you divide it by 2CD, you have 3E left that will multiply 5. You divide the LCM 6CDE by 3DE, you have 2c left that will multiply 4. If you multiply, you have 15e plus 8c all over 6cde. If you want to follow alphabetical order, so you have 8c plus 15e all over 6cde. So that is alphabetical order of the solution. Example 49, you have 3s plus 2 over 3 minus s minus 1 over 4 minus 5 over 12. This is already a balanced fraction. So you find the LCM of 3, 4, and 12. And the LCM is 12. So you write down 12, divide 12 by the first denominator 3, you have 4 that will multiply the first numerator, and numerator has 2 terms, so you put it in bracket to enable 4, open the bracket later on. You divide the LCM by the denominator 4, you are left with 3 that will multiply s minus 1. You divide 12 by 12, you have 1 that will multiply 5. So you expand the numerator and simplify. So if you open the bracket in the first numerator you have 12s plus 8, 12s plus 8, because 4 times 3s is 12s, 4 times plus 2 is plus 8. Then the next place you have minus 3 times s, you have minus 3s, minus 3 times minus 1, that is plus 3, minus 1 times 5, you have minus 5. So you add and subtract like terms. The like terms, they are 12s minus 3s, and that is 9s. You have plus 8 plus 3, that is plus 11, minus 5, you have plus 6. Okay, if you look at 9s plus 6, 3 is common. If you factor out 3, you are left with 3 bracket open 3s plus 2. The 3 you factored out can reduce 12, so you have 3s plus 2 all over 4. 3s plus 2 all over 4. Example 50, we have another balanced fraction, 1 over s minus 3 minus 3 bracket open s minus 1 bracket close all over s square minus 9. In lesson 8, I talked about difference of two square, and if you remember very well, s square minus 9 can be expressed as difference of two square because you have s squared minus 3 square. And in that lesson we said this is how you factorize difference of two square. So s minus 3, s plus 3 will replace s square minus 9 in this form before you find the LCM. So if you check the two denominators, s minus 3 is common, so you take one of it, and s plus 3. So the LCM is s minus 3 and s plus 3. So you write down the LCM. So if you divide the LCM by the first denominator, you are left with s plus 3 that multiplies 1. So you have s plus 3. You divide the LCM by the second denominator, you are left with 1 multiplies 3 into s minus 1. If you open the bracket, you have s plus 3 minus 3 times s, you have minus 3s, minus 3 times minus 1, you have plus 3. So next thing is to add. If you add the like terms, s minus 3s, that is minus 2s, you have plus 3 is plus 9. We can as well factor out minus 2 because we are looking at it such that s should be positive. So we factor out minus 3 minus 2. For numerator, you have minus 2 into s minus 3. You know the term you factor outside will divide the terms in the bracket. So if you divide minus 2s by minus 2, you have plus s. If you divide plus 6 by minus 2, it becomes minus 3. So that s minus 3 divide s minus 3, you are left with minus 2 all over s plus 3 is remaining. So you see that after expansion we still need to factorize because we are seeing a common term in the numerator. Whether what will be left can be divided by the denominator or not is not the ball of contention. You ensure that your answer is in the simplest form so that if there are common factors or there's a common factor, they can divide themselves. So always ensure that your answer is in the simplest possible form. Okay. Example 51. Given that s is equal to 2m over 1 minus m squared, and y equal to 2m over 1 plus m. Express 2s minus y in terms of m in the simplest form. Okay, in 2s minus y, already we know that this is s from the question. Then we get 2s. To get 2s, you multiply s by 2 in this form. So we can express the denominator as difference as of 2 square. You know, one can be written as 1 square, then minus m square. So 2 times 2m, you have 4m. If you express difference of 2 square, you have this result. Then y is just this. Then 2s minus y is equal to, so 2s, the result for 2s is this, minus y, that is 2m over 1 plus m. So if we find the LCM, 1 plus m is common, then 1 minus m, the two terms becomes the LCM. So the LCM is this. If you divide the LCM by the first denominator, that is 1 minus m, 1 plus m, you are left with 1 that will multiply 4m. Then minus, you divide the LCM by the second denominator, that is m plus 1, you are left with m minus 1 that will multiply 2m. So if you open the bracket, you have 4m minus 2m minus 2m times minus m, you have plus 2m squared. Alright, so you have it that 4m minus 2m is 2m plus 2m squared. 2m is common in the numerator. If you factor out 2m, you have m plus 1, and m plus 1 cancel m plus 1. Our final answer becomes 2m all over n, 2m all over 1 minus m, 2m all over 1 minus m. So that is the final answer after simplifying or expressing 2s minus y in terms of n. Alright, example 52. You have 1 minus 12 minus 3s squared over 2s squared minus 8. So let's have a balanced fraction by writing 1 all over 1. Then minus 12 minus 3s squared over 2s squared minus 8. So the LCM is 2s squared minus 8. So you have the LCM as this. If you divide the LCM by 1, multiply by 1, you have the LCM in return. You divide the LCM by itself, you have 1, multiply the numerator. If you open the bracket, you have 2s squared minus 8 minus 1 times 12, that is minus 12, minus 1 times minus 3s squared, you have plus 3s squared. So let's add and subtract. 2s squared plus 3s squared, you have 5s squared, minus 8 minus 12 is minus 20. If you look at the numerator and denominator, we can factor out 5 from numerator and factor out 2 from denominator. When you do that, you have this outcome. And s squared minus 4 cancel s squared minus 4. You are left with 5 all over 2. 5 all over 2. Okay. Example 53. We also have a balanced fraction 1 over s plus 1 minus 2 over s minus 1 plus 3 over s squared minus 1. 1 over s plus 1 minus 2 over s minus 1 plus 3 over s squared minus 1. S squared minus 1 can be expressed as difference of two squares. So this is the fraction in simplest form first, then enable us find the LCM. And the LCM is simply s minus 1, s plus 1, s plus 1. So if you write the LCM as this, you divide it by the first denominator, you have s minus 1 remaining. I will multiply 1. So this is the result you have there. You divide the LCM by the second denominator, you have s plus 1 remaining. I will multiply 2. Divide the LCM by the third denominator, you are left with 1. Multiply by 3, you have 3. If you open the bracket, numerator, you have s minus 1 minus 2 times s is minus 2s, minus 2 times plus 1 is minus 2, then plus 3. Okay, if you bring like terms together first, you have s minus 2s, then minus 1 minus 2 plus 3. So when you add, s minus 2s is minus s, minus 1 minus 2 is minus 3, plus 3 is 0. So you have minus s all over s minus 1, then s plus 1. Nothing can cancel, so we can return the denominator back to difference of 2 square. So you have minus s all over s square minus 2. See that? So it's a step-by-step solution. Okay. End of lesson 9. End of lesson 9. And the voice of Petakus is saying thank you for taking your precious time to learn and follow this lesson to the end. It's wishing you unlimited success in all your endeavors and pursuit in life and career. Don't forget, watch out for more from the voice of Petakus. Where this lesson is coming from, many more are coming your way. For inquiry, any question, any challenge, you can contact the voice of Petakus via this WhatsApp number or through the email address. For the complete package of this topic, algebraic process lesson 1 to 15 for offline usage, you can also contact him. At a very little token, you get the complete package delivered to you. Lastly, if you are not safe, you need to be safe, and the only way is to give your life to the Lord Jesus Christ, because he is the only one that has the power to save anyone. If you are saved already, I tell you congratulations. Live righteously and be prepared. Stay out of trouble. Take very good care of yourself. Stay well. Study your books. Do the needful at all times. And goodbye for now.